For over 70 years, nuclear energy has offered humanity a paradox. One of the cleanest, most powerful sources of electricity on Earth, yet cursed with a byproduct so dangerous it could outlast civilization itself. Every time a reactor lights up a city, it also creates something we don't talk about enough. Radioactive waste that remains lethal for up to 100,000 years. We've buried it. We've sealed it. We've stored it next to water, next to cities, next to fault lines. And yet, the mountain of waste grows. More than 250,000 metric tons worldwide as of 2025, with another 10,000 tons added every year. Global solutions have failed to keep pace. The United States spent decades trying to build a repository at Yucca Mountain, only for politics, lawsuits, and public fear to shut it down. Japan, Germany, and the UK have faced similar resistance. Only Finland's Onkalo repository is nearing completion. But while the rest of the world remains stuck, China may have quietly solved the problem by turning nuclear waste into glass. In 2021, China launched its first industrial-scale vitrification plant in Guangyuan, Sichuan province. The facility doesn't just store radioactive waste, it transforms it. The process, called vitrification, converts deadly liquid waste into chemically stable blocks of glass. Not just decorative, these blocks are designed to last for tens of thousands of years. It sounds like science fiction, but it's real, and it's already working. To understand why this is so revolutionary, you need to understand how vitrification works. When nuclear fuel is used in a reactor, it eventually becomes so radioactive that it can no longer sustain a chain reaction. This spent fuel is incredibly hot, thermally and radiologically, and has traditionally been stored in water-filled cooling pools. After 5 to 10 years, it's typically transferred into dry steel and concrete casks. But these casks are not permanent. They can corrode. They must be guarded. They merely delay the risk. They don't eliminate it. In contrast, vitrification starts by chemically processing the liquid waste left over from nuclear reprocessing. That waste is mixed with a set of materials known as glass formers, typically based on borosilicate glass. This is the same type of glass used in laboratory equipment and kitchenware like Pyrex, chosen for its high durability and resistance to thermal shock. The mixture is then fed into a furnace operating at over 1,100 degrees Celsius. Inside, it melts into a homogeneous molten slurry. And here's where the real magic happens. The radioactive elements don't just sit inside the glass, they bond with it on a molecular level. Once poured into stainless steel canisters and cooled, the result is a dense, solid glass block. Chemically inert, structurally stable, and incredibly tough. These vitrified blocks are remarkably resistant to corrosion, radiation damage, seismic shock, and groundwater intrusion. They don't require cooling. They don't leak. They don't crack under pressure. And because they're solid, not liquid, they take up less space and are far easier to handle. Unlike traditional dry casks that require constant maintenance and monitoring, vitrified glass waste can be stored passively, with a projected lifespan of up to 100,000 years under stable conditions. The radioactive atoms are chemically immobilized. In practical terms, that means they aren't going anywhere. China's Guangyuan facility was approved in 2004 and formally began operations in September 2021. It was built by the China National Nuclear Corporation, CNNC, and the Sichuan Environmental Protection Company, with some technical collaboration from German partners. It can process hundreds of cubic meters of high-level liquid waste each year. What sets China apart isn't just that it's using vitrification, it's the scale. While countries like France and the UK have experimented with the process, China is the first to pursue it as a core national strategy. The facility is almost entirely automated. Robotic arms handle the radioactive materials. Remote sensors monitor every stage. Human exposure is minimal, and safety is maximized. The process has been streamlined to the point where it's not just a science project, it's industrial infrastructure. But it's not just about engineering. Vitrification represents a philosophical shift in how we think about nuclear waste. Until now, the global mindset has been to isolate radioactive materials, build stronger barrels, dig deeper tunnels, guard them forever. But vitrification doesn't just contain the waste. It transforms it. It changes its form. It locks the danger into a stable, solid state that nature itself struggles to break down. This has huge implications, not just for China but for the entire planet. As nations turn to nuclear energy in the fight against climate change, they face a renewed version of an old dilemma: what to do with the waste. And until now, that dilemma has blocked progress. The lack of a scalable waste solution has made it difficult for nuclear to shake its dangerous image. Vitrification could change that narrative. It removes the biggest excuse against nuclear expansion, the fear of eternal waste. Instead of kicking the can down the road for future generations, vitrification lets us deal with the problem now. Of course, it's not perfect. The process is energy-intensive. Furnaces wear out. The glass still has to be stored somewhere, and it still requires oversight. But the risk profile is drastically reduced. And perhaps most importantly, it opens the door to new global cooperation. China is already planning second-generation vitrification facilities with higher capacity and more efficient designs. If other countries follow, we could see a global standard emerge, making nuclear energy cleaner, safer, and more politically viable than ever before. The International Atomic Energy Agency has already taken notice, urging other countries to study the Chinese model. This isn't just innovation, it could become the new global standard. In France, vitrification has existed at small scale since the 1980s, particularly at La Hague. Japan has tested vitrification at Rokkasho. Even the US has experimented in Savannah River, but none have committed to full-scale rollout like China. Now that may change. If more countries adopt this approach, vitrified waste could become the new norm. Instead of a patchwork of temporary fixes, we could build a lasting solution. This isn't just a story about glass. It's a story about willpower, innovation, and whether humanity can take responsibility for the dangerous byproducts of its own progress. For the first time in over half a century, we're not just hiding from nuclear waste. We're changing it from something that could poison the planet for millennia into something solid, stable, and still. A threat neutralized. A legacy transformed. A future made safer, one glass block at a time.